Hey, how's it going, guys? Welcome back to the series Mad About Python. This is the fifth video in this series. In case you are new to this channel, this is a series for Python Matplotlib. I have left the previous videos links in my description. Make sure you check those videos first and come back to this video. In the previous video, we have seen how to use the line plots and the bar plots, as well as how to utilize the real world data collected from a website using the CSV file, and again use that data to plot some plots and graphs. So in this video, we'll be continuing this series with the pie charts or the pie plots. So let me open a new file and let's get started with pie plots. Okay, so like any other Matplotlib program, you have to import Matplotlib first. So from Matplotlib, import pie plot as PLT. That's the same thing. Then you have to choose the style as plt.use. plt.style.use. Let me use the normal style as Seaborn. So in pie plots, if you have noticed, we'll have the sections known as the quantities or the categories. Now the pie charts is very similar to your bar charts where you give the x-axis and y-axis, but here you have to define the slices. Now the first we will use very simple data and plot a pie chart, and then we'll use a real world data and plot the pie chart. So nothing much. The proportion quantities and the variables will be same. If you are giving something out of 100, then that proportion is divided and plotted as a pie slice or a slice in a pie chart. Okay, so let me give some variable like x, and in this I can define my list. Here I can give some value like 40, and let's give 80-20, okay, something like this, 80-20. And then I have to give the label. So I have to give the labels as something like value A, and this will be value B. You can give anything here. Yep. So once the label is done, it's very simple. plt.pie instead of plot we used last time, which is plt.plot. You have to use plt.pie. Now inside this you have to define that variable, which is x in this case. So x and x and the labels will be labels. That is this variable we have defined here. Okay, so that is it. You're almost done. Now we'll give the rest thing like plt.title, first pie plot, something like this, and then our usual tight layout. So this is for the screen resolution. Then plt.show to show the output. That is it. Let me hit F5 and run this. Okay, so as you can see here, our plot style is of the type Seaborn, and I have not given any color. It is by default blue and green. So your plot will look something like this. As you can see, the label value A and value B, now it is in form of 80-20, which is taken out of 100. Now that doesn't mean you have to always choose the values out of 100. Matplotlib is smart. You can give the values as you like, and that proportional value is taken up by Matplotlib, and then those slices are divided accordingly. So let me change this something like 120 and 40 and run this again, and you can see it for yourself. Yeah, as you can see here, it is giving values like this. Okay, so problem with this plot is there is no border given to it, and there is no distinguish line which shows that this value is related to the value A or B. So for that we will be using something known as a wedge prop. Wedge prop, let me show you. Let me take you to the Matplotlib documentation page. As you can see here, the wedge property in Matplotlib, we'll be using something as the edge color. So you can give the edge color which is of black. It is nothing but basically borders given to your slices. So inside this the plt.pie, you can pass a dictionary for this. It is always a dictionary for this kind. Make sure you use the round brackets, not the square brackets. Now inside that I can pass edge color. Now this color will be of value black, something like this. And let me just run this now, and you can see it for yourself. It will have a wedge as black. Okay, I hope you can see the black line around the blue and the green slice. Let me just change the value and show you for a better view. Let's go back to 6040 and change this black to red. Let me hit F5 again. I think it'll be clear now. Yeah, I think you can see a thin line here which is of the color red around the pie plot. So that is the wedge color. So now that you have seen the basic pie plot, let me just change the style. Instead of Seaborn, I have taken 538 as my style, and let me put some extra values here. So we'll take like 20, 50 and 30 and 10 like this, and let's increase the label value as value, oops, inside quotes, value C, and we need another value that will be value D. Okay, so we have 4 slices as well as 4 labels. Okay, so let me show you how to add colors to it, because the Matplotlib will choose default colors. Just in case you need your own customized colors, you can pass here the same thing, the list, and inside this list you can pass the color. You can pass the colors like red, blue, green and the default colors, but it won't look nice on these pie charts, trust me. For that you can use the W3 School's hexadecimal color picker. So you can choose your customized colors from this palette right here, and then you can paste those hexadecimal values in the color list and it will work just fine. So let me just pick up my 4 unique colors and let me just paste it there. Okay, so now I have changed my color list. Now you can see here 4 unique hexadecimal values, as well as the labels are having four values for the X variable. Okay, so let me just hit F5 and run this. There you go. So this is your plot having values A, B, C, D, and the hexadecimal value colors are inserted here. So it looks really nice, as you can see. Okay, so this was your simple pie plots or pie chart. Now let me utilize some real world data. We will utilize the same data we have taken from the CSV. As you can see in the last video, we have used something known as the Stackoverflow annual developer survey data, where we had the responders giving the languages they have worked with and the number of people using that language. So let me just delete all this and use the real world data, and let's see. Okay, so now we are using the real world data taken from that CSV file. So as you can see here, first thing we have is JavaScript, HTML, CSS. Now 59,000 people have used JavaScript, and CSS is HTML and CSS is used by 55,466 people, and the list just goes on like this. And you can put anything here, you can put your random values, and just make sure the number of values are given here, you have the equivalent labels for those values, otherwise it will show you the dimension error. Okay, so now let me just plot this. As you can see, I have changed the title also. It is Stack Overflow Data 2020. Let me just plot this and let's see how it looks. Okay, so you'll be getting something like this, and the problem with this is when you have more values, it is not suitable to use the pie chart or the pie plot. In that case, it is better to use the bar plots to represent the data. As you can see here, I am not able to make out the percentage here. By looking at this plot, the C#, PHP and the C++ data almost looks the same, and even the color is not maintained properly. So it is always better to use pie charts or pie plots when you have less data. Suppose you have to show the top 5 languages maybe, or you have to show anything below 10. So now let me just reduce the amount of data, feed it to the pie plot. We'll just take 5 values, and the last one will be bash. Great. So we have 5 values and the 5 labels ready. Okay, so this plot would look something like this. Let me just hit F5. I have not given any colors till now. It will be by default. As you can see, this is something like this. Okay, now I wanted to show you something which is known as the explode. Now it's important if you want to focus on a specific data. Suppose I want to focus on Python only, so I will explode the pie plot, and just to differentiate the Python slice, I will use the explode. So for that, you have to pass something known as explode here, and in this just take care here. In this, you have to mention the values of the percentage of radius. So if I'm giving 0 here, that means the Kotlin will not explode. That is why it is 0. Same way, if I want to give 0 for here, again C++ won't change. Now it comes to Python. So Python is the third value in the list. So I have to change the third value in the explode list as well. So I'm going to give some value like 0.1 or like 0.2, which is nothing but the 20% of the radius in the pie plot. So 20% of that area will be exploded and it will be separated out. So I told you I will be focusing on Python, so that's why the JavaScript and bash will be 0 again. Now you have to pass that explode here in the plt.py parameter. So in this I'll give the explode equals explode in this case, which is our variable. Great. So let me just run this again and show you how it looks. As you can see, the Python data is exploded. Okay, it is touching the label on top of it. Maybe I should change the value to 0.1. So now it is going to explode only 10% of it. Let me just rerun this. Oh yeah, now you can see here your Python is separated from the pyplot. This is done just to highlight a specific label or a specific slice in the pyplot. So this is how you can use the explode. So we are coming to the end of this video. Let me just show you 3 more concepts in this video. And let's just see how to add the shadow effect or the 3D pop-out effect. So that will be something known as shadow in the plt.py parameter. So here you can give some space and add shadow equals true. Now what this will do is give you something known as the 3D pop-out effect. As you can see, there's a little bit of shadow falling this side and as well as for the pop-out slice. So that was the shadow effect. And what else? Let me give the start angle. So you can specify how to rotate this chart in case you want to start, and this you can specify like 90. We give comma here, and what it will do is it will rotate your chart by 90 degrees like this. So it starts from here and ends here. So that is the start angle starting from 90 degrees. And at last, if you want to specify the percentages, because we have not defined the percentage here, so what you can do is use the auto PCT, which is also known as the auto percentage. So it goes something like auto PCT. Now you have to remember this weird command. So this is given by percentile 1.1. So percentile 1.1 F percentile. So this is how you can give the percentage to your plots. And let me give the comma here, and that is it. Let me just run this again. Now you can see the percentages will be on top of the slices, on top of each slice. So here you can see Python is 15.6%, JavaScript is 28.1, 37.5, and that is how you represent the auto PCT in pie chart. Okay, so just to summarize what we have seen in this video, we have seen how to create the pie plots in Matplotlib. Now for that we have used the Stack Overflow data again, and as you can see in this picture, we have created this pie plot which is showing the percentage and how much portion each language is occupying from that data. Okay, great. So the first thing we learned today, that is the slices. So your pie plot will have these slices. Now these slices are nothing but the data given to this. Now in this pie plot, as you can see, the majority is given to the first value, which is around 75%. Then the second value is having around 5%, and the third value is having around 20%, let's say. So the whole is 100, and out of that we are getting the 3 values. So inside the slices, we are basically giving the values like 75, 5, 20. So these are nothing but your slices. Then we learned something known as labels. Now these labels are given to name these parts or these slices. So I can give these value as A, B, and C respectively. Now these values are assigned something like this: A,
and B will be 5 and C will be 20 in Python. So your A is nothing but this 75, your B is nothing but 5, and your C is nothing but 20%, like that. Okay, so for the programming, we are using the plt.py. So plt.py, and inside the parameter, we are passing the slices. And just after the slices, we are passing the labels, which is nothing but labels in this case. And so that is the command to create the pie plot. Now in this same command, we can pass the labels, the colors, and we learned something known as the wedge props. So wedge props are nothing but the borders given to your pie chart. As you can see here, the white line here is nothing but my border. If I cut this part out, something like this will be my wedge. Now your wedge prop is containing a dictionary, so this can be defined like wedge prop, and inside this dictionary, using the curly braces inside the dictionary, we can pass the edge color. So edge color equals, let's say, black, and this black, yeah, something like this. Now this black color will be given to the edge right here. Now let me just change the color of the wedge to show you how it will look. Okay, so instead of black, let me just take blue here. So the wedge color will be blue, and here you can notice your wedge color like this. So instead of the black or white, you can give your wedge color as blue. So your outlining of the whole pie chart will be in blue color. Now in the same plt command, you can pass the colors as well. So plt dot plot, and inside this you can pass the slices, you can pass the labels as label because you're using the same variable, you can pass the colors as color, whatever color you want to use. For that, we are using two different lists in Python. So your label here and the color here will be contained in two different lists. So for that, we are using the Python lists and giving the labels like this separately, which is a better convention, I feel, because it will take out all the confusions, and it is easy to notice which color is for what slice. So I can give here something like red, then I can give green, then also I can give blue here, something like this. Now in the color section, you have the option of choosing the default colors, or if you want to choose the hexadecimal color codes. So I can use something like hashtag 008FD5, or for blue I can use hashtag 6D904F, something like this. So you have the ability to choose the default set of colors or the hexadecimal color codes as well. Also in this video, we have seen the three customizations, namely shadow, start angle, and explode. Now what shadow does, it gives a 3D type of lift to your pie chart. So if you do the shadow command equals true, what you'll get is, you can see here, there's a lift, or you can see the shadow around the yellow and the green slice. So that is the 3D effect. Even in the blue, you can see a slight gray line going through that. So that is nothing but your shadow. So if you give the shadow equals true, you can get the 3D effect. Now coming to the start angle is something which you do when you want to rotate your pie chart. So you can rotate it by 90 degrees or rotate it by 180 degrees, something like that. So you can give start angle like this. So start angle equals 90. Now what this is going to do is, it is going to rotate your pie chart by 90 degrees. Just for an example, I have taken 90 degrees. You can give your own values here. Now coming to explode, which I feel is the important feature when you want to highlight. So for highlighting purpose, you want to highlight a certain value. In case you want to highlight a language in our data, which is Python. As you can see here, I have highlighted Python, and you can see there's a gap between the yellow and the green, which is Java and C++, and Python is somewhat separated. So that is the power of explode. Okay, now how to give explode? Now you have seen the list we have taken earlier. We have taken the list for the label and for the color. The same thing you can do is for explode. So explode will be another list, and as you can see, we have 4 values here. We have taken 4 languages, namely C++, Java, Python, and Kotlin. Now I want to highlight Python, which is the third value here. So I have to give 0, 0, and the third value I want to explode it by 10% and again give 0. Now Kotlin is 0, your C++ is 0, your Java is 0, but your Python here, the third value is 0.1, which is nothing but 10% of the radius of the pie chart. What it does is, if you have the pie chart like this, and this is your 10% right here, if this, imagine this as your 10%, so this is exploded out. So when you get the pie plot, it will look something like this. Your pie chart will look exploded. You get value something like this. So this is nothing but your Python language, because we have given explode value as 10% of the radius. So this value is
Okay, so that's all for this video now, and I will see you in the next one.